Alright, so let's get started with lecture 3 on floats and loops, and I'll also try to, let me write it down so that I remember actually, to get into some functions as well today, because you'll be doing that in your next lab. Let's see here. So yeah, let's go ahead and get started. Here is a question that I think you can answer from last time, so please take a moment to just pause the video and think about what's going to be printed out when we print out sum. I don't know why the variable's called sum, by the way. We should maybe change this to like j, but that's okay. So if you were to print out sum, what would you get? And take your best guess. While I bring us to a nice file that looks almost like this, that does this. Okay, so I'm going to make a new file with this code. And here I am in my code from class folder, which is deep inside my desktop, CS16, all these folders. I want to make a new folder inside of this one called lec3. So I'll say make dir lec03. And now I have it. I can go on into it by saying cd lec03. And now there's nothing there. I would like to make a file, just a blank file to start with, called, I don't know, integer division, because that's the topic of this particular question. And there's a command to make it just a blank file in the current folder, and it's called touch. So I'll say touch integer division.cpp. And so now I have this blank file in this lec03 folder that I can now fill with this code that we cared about. Oops. With this code that I had highlighted, and apparently it became unhighlighted. So let's start out with our usual stuff. We want to print stuff. So we're going to say include IOStream using namespace std, and then we'll have a main function that, if it can finish, well, it'll return 0, because that's the success exit code. And let's make this, instead of saying like sum, let's have it say like, I don't know, double J or something. Oops, and I don't want to be in caps lock. So now if we print out J and a new line, what do we get? Well, let's find out. Let us do g++, integer division, -o, integer division, and go ahead and run that. And oh man, do we get 0. So the idea is, this is a case of this thing called integer division, where even though we're assigning to a variable that is a double type, it can hold decimals, this division operation is being done on an int on the left-hand side and also an int on the right-hand side. And whenever that happens, you get this thing called integer division, which just drops all the decimal places, and that's not what we want here. We would really like this to be equal to 1/10 0.1 and to have that printed out. So the way to do that is to make one of the sides of this division operation either the 1, a double, or the I itself a double. And you can use casting or say things like 1.0 or things like that. I think in this example we're just going to cast the other side. So let's make the I a double on that right-hand side of this division operation. Static cast into a double, please, of I. So now on the right-hand side of this division, I is a double value. And so this should hopefully print things out nicely for us. So if I recompile, rerun, we get 0.1, which is what we wanted. But there are fancier ways to print out your doubles. You can set options on cout. You can set what are called flags, just another word for options, to do some special things. And what this is going to do is 3 different things. The first one that makes the most sense is to always show the decimal point. So say your double held the value like 10 or something. Really, as a double, it's 10.0. But if you were to output it, it would just say 10. So show point will always show the decimal point. And fixed is always use this thing called a fixed point representation, which I think means that it'll never say like the times 10 to the whatever. So 100 is the fixed point representation, and that is separate from like this other way of writing this number, which is 1e to the 2. Okay, so that's a different way. This is the same number, and the e here, if you ever see that printed out to you from C++, it just means times 10 to the whatever. So this is 1. It's equivalent to 1 times 10 to the 2. Okay, so we're saying don't do that, please. And then also precision. What do you think precision might mean? Make that 3. So take a good guess as to what will now be printed out, and we'll come back. Okay, let's see if I can just copy this, because that would be wonderful. So maybe I'll include some comments as well. Oops, I wanted a space. We need one of the sides of the division operation to be a double to perform double division. Okay? And here are our 3 lines that do stuff to the way that cout prints out doubles. And let's go ahead and compile and run this now. I'm pressing the up arrow to get at the my recent commands. And oh man, that precision just meant three decimal places of precision after the decimal point. If you didn't ask for that, it would just stop it when it got to all zeros. Okay, so the answer here is 0.100. I hope it makes sense now. You'll be reading about this in your book if you haven't already, these kinds of options to give to cout. Okay, so now on to stuff from last time. We'll go into a little bit more depth. So in C++, you have loops, just like in Python or any other language that you've come into contact with. You can do the same thing a bunch of times. And a for loop is a nice way of doing this kind of repetition. And we usually use for loops when we have a fixed number of times to repeat this body in mind. Like we want to do this thing exactly 100 times. Whereas a while loop will do it, we will tend to use that when we don't know how many times our loop body should execute. There's a more complicated thing that guards against when we stop looping. Okay, so that is a for loop, and let's use for loops to write a program that calculates this series, 1 plus 1/2 to 1/3 plus 1/3, all the way to 1/n, where n is given by the user. And just like last time, I want to go over the syntax for a for loop. You have, you say for, and then in parentheses you have this kind of initialization, semicolon, condition that stops the loop, semicolon, increment that says what to do after the body's executed to get ready for the next loop. And here's our body, separated by, of course, these braces. And the way that for loops are run is first, once and for all, we run this initialization, which maybe makes some variables, like sets up x to be 0. And then we have our loop condition, which tests whether or not we should execute the body. I'll call that 3. And then increment does what we need to do before we can retry this condition and re-execute the loop body. So when you go into a for loop, you start off doing the initialization, then you check the condition, and if it's true, you'll execute the body once, and then you'll always come back after the body to re-execute the condition and look at it and see if you should redo the loop. And if it just so happens that your condition is now false, it's very possible for your condition to initially be false. You see that? No problem. Then you're done with the loop. Okay, so that's the idea of a for loop. Let's see if I can zoom out and put that all in one big place. So that is that. Okay, so now let's use this kind of for loop to do cool stuff, like calculate the series 1 plus 1/2 plus 1/3 all the way to 1/n. And let's have that number be entered in as a command line argument like we talked about last time. So let me make a new file. I'll just cheat over here and use my editor. Let's do sum series.cpp. And I'll bring in a lot of this boilerplate stuff because we'll use it again. But here's the idea. So let's get a number from the command line arguments. Then we'll have that number, let's call it like, I don't know, int n. We'll get that in some way. And then we need to calculate this series using a loop. Okay, and we'll have to figure that out using a loop. And I think it'll be a good idea to make a variable that holds this result, because every time in the loop body, I think you can imagine that we're going to start out adding one, then 1/2 in the next iteration of the loop, then 1/3 in the next iteration of the loop, then 1/n in the final iteration of the loop. So let's have a variable, double sum, to start that out with. And of course, let's initialize that to be 0, okay? Because that is the unit of the addition operation. Okie dokie. So let's figure out how to get command line arguments again. Remember, you can give main 2 arguments now that allow you to get the command line arguments that are given to you from the terminal. So right now, this is main not accepting any command line arguments. And let's let it do that now. So int argc tells us how many command line arguments we got. And then we have char star argv brackets for the argument vector, or the list of, you can think of it as a list or an array of strings. That's a special kind of string, char star, of all of those parameters. And we will have this be argv of 1, because remember that the name of the program, when you run it, it's like /foo, and then 42 is your command line argument. This would cause argv to be /foo, that's always in the first part, and 42 in the next one. So remember that this is going to be index 0. We're looking for index 1. That's where our number is going to be. Okay? So we're going to do a2i argv of 1, because a2i will convert this string into an integer. Okay? And if you ever are confused about where these library functions live, this one happens to live in C standard library, cstdlib. You can always go to Google and say C++, cstdlib. What in the world is there? And this c++.com is going to save your life this quarter, and possibly the one after it if you take CS24. So this will tell you exactly what's in all of these headers that we've been using. These ones are specific to the C language. You can also make these bigger and see what's going on here. You can see what's in IOStream. Oh, it has C in and C out. And we'll also talk about C error today. And then some other things. But what we're looking for here is A2I. And you can click on it to see more information about it, some examples. But yeah, it's going to convert a special kind of string to an integer. It's going to return it as an int to us. Okay? And that is what we want here. Also, when we run this program, we need to make sure that we were given the right number of command line arguments. So make sure we were given the right number of command line arguments. Okay? And the way to do that is with an if statement. So we need to make sure that the number of arguments that we're given is always 2, because we have the name of the program and then also the number that's being called with. So if argc is unequal to 2, we should stop the program, right? We should say cout, you gave us the wrong number of command line arguments. And then we should tell them what you should have done. Cout usage. So we don't know what the user called this program when they compiled it, because you can compile it to any actual thing. You don't have to call it some series. But we'll always have the name of the program in argv0. So you can say, it doesn't matter how you called the program. This is how you should have called it, and I know exactly how you did, what this program is called. It is in argv0. argv0 and then a space and then n. That's how you should have used this program. Okay? And then we will exit the program here by either returning, because we're in the main function. If we return from the main function, it'll quit the program. So stop the program here, because we don't want to continue. You can also, from anywhere in the program, call the exit function, which just stops the program. And this also lives in this cstdlib library. It's right here, exit. What it does is terminates the process. In our case, our entire program is just this one process, we call it. And we're going to give it a status code, how we want to return to the terminal. And we're not going to return 0 because that means success, the program executed correctly. We're going to return 1 because something went wrong, just some non-zero number. Okay? And that brings us to another thing that I want to talk about, and that is error output. So cout is meant for like standard output things to the user. Cout is meant to output normal information to the user. Cin, of course, is to get information from the user. There's a third one, cerr. Cerr is to output all error information. So if anything goes wrong and it's technically an error, we should be using this thing called cerr. It works slightly differently, but you don't really see the difference on your terminal. It's going to look exactly the same as had you printed this out using cout. So let me call this program incorrectly so that we get the idea. G++, sum series, -o, sum series. So I'll call it without any arguments. It's like, oh man, you gave us the wrong number. This is how you should have used it. And you see how it's getting the name of the program from the first argument that we gave to the command line. It's beautiful, huh? So yeah, that's that. And you can see how this is just printing stuff out to us again. We can't tell when we're using the terminal that we got error output as opposed to just normal output. But the terminal definitely knows, and there is definitely a way as well to tell, hey, did this thing get printed out as an error, or did it get printed out as just normal text? And if you're interested in that, I invite you to come to one of our office hours so we can tell you exactly how to see the difference. Okay, back to this program. So remember, our end goal is add up all of these numbers, okay? So let us begin. I am going to simplify this. Actually, no, let's start this out as a loop. So how many times should our loop execute? Because we want to sum these numbers, 1 plus 1 over 2 plus 1 over 3, all the way to 1 over n. So how many times, so if we have a loop that does this summing, how many times should the loop body execute? Well, 1, 2, 3, it looks like we should iterate n times, n iterations of this loop, okay? So let us make a for loop that brings our numbers between, that iterates n times, and let's have our number go from our iteration loop variable, go from 1 to n, because I think you can see that 1 is just the same as 1 over 1. Now you can see that we can do the same thing every time in our loop body. Just add that to our current sum. Start with 1 over 1, and then the next iteration, when our iteration variable happens to be 2, sum 1 over 2 now. Or add 1 over 2 to our sum variable, I mean. So let's start making our while loop, or our for loop, sorry. So we say for int, and then some variable. I'll say I, that's our iteration variable. I starts out being 1, and let's continue our loop as long as I is less than or equal to n, and every time we iterate, we want to increase I by 1. So now this will cause I will go from 1 to 2 to 3 all the way to n. And now all we have to do is add to our sum. Sum equals sum plus, and now we need to do 1 over I, right? But of course this is not what we wanted because I is currently an integer. Let us make this part a double static cast double I. And so now you see the point of all of those first slides. And there's actually shorthand for this. If you ever have, like, I'll do this on the slides or on the whiteboard. If you ever have a case where you say x equals x plus 1, you know that that's going to be x plus plus, the shorthand for that. But there's another shorthand as well. So if you have like x equals x plus, I don't know, y, that shorthand can be x plus equals y. And there are similar forms of this to for other operators like minus equals, times equals, divide equals. It's always, this means that x equals whatever it was plus itself plus this y. Okay? So I can say, instead of this, I can say sum plus equals 1 over I. Okay? And then we'll output sum. And I think that's all we want to do here. And let's run this program, see if it's working, and see if I made any mistakes, because you're not here to shout out at me when I do make mistakes. So let's call it with a real number. So let's do 1 to 1. This should output 1. And then if I do 2, that should output 1 plus 1/2, which is 1.5. And then 3 is a fancier number, and I think that's probably going to be okay. So does this actually go to something? No, this is a harmonic series, right? That's it's never going to approach a number. Never mind. But cool, I think we did it. So that is that, and of course you're going to have this code, so please study it, and it should be very helpful for your homework. Now let's get into while loops. A while loop is just another way of repeating things. It's a way to repeat code where you have some condition that's always that's true for a certain amount of time. So the way we do a while loop is we say while our condition is true, please execute this body. And that's what we have. This could be 1, this can be 2. So we're coming into the loop. We immediately test the condition. If it's true, we execute the body of the loop. If it's false, we're done with the loop. So it's very possible to get into a loop and never execute its body. Not an issue. All right, that's a while loop. It's a bit simpler, and it's exactly like the while loop you've seen before in another language like Python. So that's quite nice. So let's do a few things. So let's have an example of just different kinds of loops, actually, because this will probably make things a bit easier. So after I give these examples, maybe you can come back to this file and it'll make a bit more sense. So let me make a file called loops.cbp. Here we go. Let's include iostream. Let's include all these, because why not? Make a main function. And let's do, just print out the numbers from 1 to 10, you know? So here is a for loop doing that. Int I equals 1, I is less than or equal to 10, I plus plus. We'll see out I and L. So this is a way to print out from 1 to 10 using a for loop. So g++ loops dash o loops. And oh man, did we do it? Very nice. Let's now do the same thing using a while loop. So again, we'll start out with our integer I, starting out with 0 or 1 here. And now our condition can be while I is less than or equal to 10. We will print out I and then increment it so that we're ready to do the next part of the loop. And eventually we're going to stop because I will become 11 at the very end of this. So you can see how I is going to range in this loop between 1 to eventually 11, and that's going to stop the loop. As we'll say, when I is 10, we'll print out 10, then we'll make I 11, and then we'll come back to check this condition again, because we always come back after we're done with the body to recheck this condition. And at that point, we're going to notice that, oh, I is 11, we're done with this loop. Okay, so this will also print out 1 to 10. Let me give it some space. And here we go, 2 1 through 10s. And that's the idea for that. That is a while loop. There's another kind of loop called a do-while loop, and it's quite useful sometimes. It's a while loop that always executes its body at least once. Because you can see in this case, it's possible to just skip the entire body of the while loop. Sometimes you have programs that have this body needing to be run at least once, even if the condition happens to be initially false. So the way to get around that is using a do while loop. So you say do, and it kind of is self-explanatory because the body is in the syntax specified before the actual condition. So do the body first, once at least, and then check the condition. So I don't know, let's call this 1, then 2. So a do while loop executes like this. We come into the loop, we initially do the body always, and then we come back and check the condition. If it is true, we'll go back to the body. If it is false, we are done with the loop. And you can see how we're always going to at least do the body once. And here is our condition checking at the end of that. It's possible to convert a do while loop into a while loop, and it's also possible to convert a while loop into a for loop and vice versa. All of these loops are interchangeable. Every loop can do just the same amount of stuff as the other. All loops can be, well, while is kind of like the simplest loop, so let's talk about that. Can be transformed into a while loop. That's like the simplest one. You can also go the other way, not an issue. But let's talk about converting a do while loop to a while loop. So a way to do that is do body while cond. You can transform that into the following. Just always do the body once, bring it outside the loop, and then have a while loop with the same condition, and repeat the body inside of there. I cannot draw a brace today to save my life. Body. And now you have the body again. So you see how this will do the same thing as a while loop instead of just a do while loop. So that's what a do while loop does. And so it's possible to execute the body at least once, even when the condition is false. Let's see here. Let me give you an example of that. So do, I don't know, cout, let's do int j equals 11. Cout j, new line, j++, while j is less than or equal to 10. So this is supposed to try and count from 1 to 10, maybe. But j starts out being 11. So we should never, in the while loop case, ever execute this body. But in the do while loop case, we're always going to try the body at least once. So this should output just 11. Okay. There we go. There's our 111. Beautiful. Okie dokie. Moving on. So one really nice thing about for loops is that it allows you to do this kind of nested iteration in a controlled way. So for example, it's very easy with nested for loops, we call them, for loops inside of for loops, to draw this kind of square, and that'll be useful for a future lab. So let us make a program that draws a square of a given width when we give it to the user. So this is going to be a 5 by 5 square of stars. All right. So let's make a function, or a file called that. So touch draw square.cpp, and then we're going to get command line arguments. So we better make our lives easier and just copy all that stuff in from some series. Boop. Boop. We can actually keep all of this. Now we have n, and then we do something different with our n. Okay, so now we're going to draw a square. An n by n square of star characters. Okay? And the idea is we can do that with nested loops. And let me give you an example. So let's do like a 4x4 square of stars. 3, 4. The idea is you can worry about printing. This can be like our basic amount of things to do. Print 4 stars. We can make a loop to do just this, right? Print 4 stars. This is assume n equals 4. So we would print 4 stars, and we do that 4 times. Do you see how there's like 2 loops involved here? We copy and paste for effect. Oh no, this one's not really in line with the others. There we go. Print 4 stars and a new line. And then do that 4 times. Do you see that? There are 2 loops here, one inside of the other. So there's an inner loop where you just print 4 stars. You iterate from 1 to 4, I guess, and then always print a star. Then, outside of that, you do that printing of 4 stars 4 times in total. And if that doesn't make sense, I'm going to code it up right now, so don't you worry about it. But that is the idea of nesting loops. We'll always try all the possibilities, get all of those numbers. So the idea here is, let us make a double for loop, doubly nested. For int I equals, it's common to start with 0 and iterate as long as I is less than equal to n, and this will always iterate n times still, I++, so iterate n times the outer loop. And then inside of this loop, we're going to have another loop. Oh man. So now, inside this loop, I'm going to have another for loop. For int j equals 0. J is less than n. J++, do some stuff. So this will iterate j times the inner loop. So the idea is, what is this for loop but just the body of this for loop? So every time, every iteration of this for loop, we are going to execute this for loop again. And that's the idea of nesting loops. So let me see out here in this case, I, then a space, and then j, so we can see what's going to happen here. The idea is we're going to start out with I being 0. So I will start out as 0. And then we're going to go inside of this loop and execute its body. But its body is a for loop, so we're going to make it int j, start it out being 0. So now we're going to make a j. And, oh, is j less than n? Let's say n is like 2. Yeah, sure it is. Let us execute our body. Print out ij. We'll print out 0, 0. And then increment j, and go back to this for loop, because this for loop is the body of this for loop, and we need to complete this entire for loop once before we ever go back to check this for loop's condition and execute its increment statement. So j is going to get incremented. We're going to come back here and print out 0, 1. And then now let's assume that n was 2. We're going to stop this loop. Now we're going to come back and increment I. I is now 1. And j doesn't exist yet, because every time we make this body, we get to make these new variables all over again. So now I is equal to 1. Let's execute the entire body of this loop. Let's start out j being 0 again. And j will end up outputting 1, 0, and 1, 1, because j will eventually be set to 1. And this is all assuming. Assume n is equal to 2 here. Okay, so that's the idea. And so now you can see how I and j, like the pairs of those numbers, are going to always be iterating in this kind of fashion. If n was equal to 3, we would see this printed out, 0, 0, 0, 1, 0, 2. 1 0 1 1 1 2 2 0 2 1 2 2. So you can see like all the pairs, all the possible pairs of these two numbers are printed out. And my computer is working very hard on something right now, so sorry if things get jagged. Okay, that's the idea. And we can use this to always print a star. So in our inner for loop, we can print a bunch of stars. Because at the end of the day, this is going to print a certain number of times. So, and these loops, these loop iterations, they get multiplied. And that's the real key that I'm trying to get at here. When you have nested loops, the number of times the inner loop's body is executed gets multiplied. And let me show you what that means. So back to our normal example of draw a square 5 by 5. We'll have one loop, the inner loop, that worries about printing this star 5 times. So if n is 5, only look at this one right now. So we're going to iterate from 0 to 4 and print out a star. No, and let's not have a new line. So this loop has just taken care of printing out one line of this square. Now we need to do that same thing 4 more times. So in another loop, outside of it, we're going to iterate again, also between I going from 0 to 4. Because now this will allow us to print 4 stars, or 5 stars, 5 times. Okay? That is the key here. So let me show you this working, almost at least, and let's go from there. So G++, draw square.cpp-o draw square. Oh, I need to give it a number. Let's give it like 3. All right, let's go all out. Let's do 5. You will notice that this will output 25 stars if you count them. That is the whole point here, because j will range between 0 and 5, just like this. So I will start out at 0, j will also start out at 0, then we'll go from j 0 0, print out a star, j is now 1, print a star, j is now 2, print a star, j is now 3, print a star, j is now 4, print a star, and now we're done with the inner loop's body, so we go back to the outer loop, increment I, make j something else again, start out being 0, print a star, start out being 1, print a star. And you can see how this process is going to repeat for 5 different lines of stars. And the key thing that we need to notice is after we're done printing our 5 stars, we need a new line. So right here, if we see out a new line, this is just a single character, so I can put it in single quotes actually, then we're home free. Because what this is going to do is print 5 stars, that's the inner loop, then print a new line, and then do that whole thing n times. All right. So this inner loop worries about printing a single line of n stars. And this outer loop makes sure to print n lines of n stars, because that's what the inner loop is doing, is printing n stars, right? That's the whole point. And all we have to do in the body is print that line of stars and finish it off with a new line. Okay, so that's going to take some time to sink in. Please think about that. And another way to think about this is I and j here. In the loop above, I and j range between all values, starting at 0, 0. So if I is the first thing and j is the second thing, to 0, 1, all the way to 0, n minus 1. And then we do that again for 1, 0, 1, 1, all the way to 1, n minus 1. And all of this entire process goes to n minus 1, n minus 1. So I and j together as a pair, we produce all pairs between 0, 0 and n minus 1, with every number in between. That's a key for a next example in this. But just in short, think about separating your concerns here and worry about printing the first line and then duplicating that work to print the second line, the third line, the fourth line, the fifth line. And hopefully that'll make some sense. Okay, so that's nested loops to draw a star, or to draw a triangle, or a square, excuse me. Draw a square. Now, let us use the same process to draw a triangle, where we don't print out the same number of stars each time. We print out a different number of stars. And this is a bit fancier. Technically, this example involves stars and spaces. So something that we can go back to doing is add a space here. It looks a bit fancier. So now we have, every time we print a star in a space, star in a space. But that's just cosmetic. So instead of drawing a square, let's try and draw a triangle instead. And it just so turns out that you only need to output or to change one of these lines. Please think about which it should be. I actually haven't included this line in my code. It's not really necessary. Okay. What would you modify? And let's think about it. So the idea is every line we draw a different number of stars. So which for loop talks about the number of stars to draw on a given line? It's not this outer one, because that tells us how many lines to draw in total. The outer loop works on the number of lines in total. So we always still want 5 lines. So we don't change this one. And this one, we should be changing actually, because when we're at the first line, we should draw 1 star. When we're at the second line, we should draw 2 stars. So this iteration variable shouldn't be n anymore, and that is the answer here. So B means that we need to change this line to something else. And let's figure out which one. Let's do draw triangle. Draw triangle, that's CPP. And where do I say square anywhere? Oh, I don't. Okay, cool. We're just going to change this to be not n. Don't go to n. And in the example in the slides, we use j for the outer loop and I for the inner loop. It doesn't really matter. They're just variables. So I'm using j for the inner loop and I for the outer loop. So this loop worries about printing a single line of n stars, but we're going to change that. We're still printing a single line inside of this loop, but how many stars we print depends on the I actually, because just like for these line of stars, let's say it was 4 by 4 again. Actually, I can go back up to the example up here. This is I equals 0, I equals 1, I equals 2, I equals 3. Always print 4 stars. Now, when I is 0, we need to print 1 star if n is 4. Assume that. If I is 1, we want to print 2 stars. Okay, if I is 2, we want to print 3 stars. And if I is 3, we want to print 4 stars. So it's always print on each line I plus 1 stars. I hope you see that. So now all we need to do is change this to not go n times, but I plus 1 times. All right? because this will let j iterate between 0 and I itself, because we're always strictly less than I plus 1. So this will iterate I times the inner loop, which is interesting in itself. And this is also supposed to be n times the inner loop. Sorry about that. Okay, so now the j depends on the I. That's the key. Oops, I'm still drawing squares. Draw triangle, please. And let's do draw triangle, and 4, and 5. And again, the key is that the j, the inner loop's iterations, depends on the I here. It's always I plus 1 times for your inner loop. Okay? So that's the key there. And that brings us to a few more slides. And this first one is about infinite loops. So here are a bunch of different ways to make infinite loops, and let's talk about why they are infinite loops. So the first one is an infinite loop because y starts out as 0, and y starts out being 0, and we want to continue this loop while y is less than 10. Okay? So is y less than 10? Yes, it sure is. So we'll print out this line once, print forever, and then we'll do our y minus minus. So now y becomes -1. Now you see where I'm going with this. So we come back to this loop. Well, is y less than 10? Yeah, of course it is. It's -1. Well, we'll print out, and then we'll subtract from it again. So now y is -2. And you can see how this is always going to keep on decrementing I, and it'll always still be less than 10. Okay, that's the problem there. Technically, when we talk about integer arrangement in memory, this will eventually wrap around to a positive number, but we're not going to talk about that right now. Assume it's an infinite loop for now. This one, we'll start out y being 0, and this is a bit odd. It's possible to leave parts of a for loop blank. So the initialization here, there isn't one. The condition here, there isn't one. So it's like saying while true almost. Okay? So the condition is always going to be true. So we start out y being 0. Our condition is blank, which means it's true. So we'll just keep on printing print forever and also incrementing y. But we never check it. We never check y because there is no condition here. Okay? This one. Again, we can leave parts blank. There's no increment statement here. But you thought that there was. Let's put it in the body. But oh no, there isn't actually a body. The trick to this one is there is no real body to this for loop. Oops, that is not a good enough screenshot. There we go. So here, oops, the issue is that, you know how I told you about always including those braces because it might bite you one day? Here it is biting this person. So this for loop has an empty body by virtue of this semicolon. Because even though you have indentation means nothing to C++. So here's its blank initialization statement. It's got a condition. It's got no increment statement. So y is going to be stuck at 0 because this for loop, it's as if you had written two braces just like that. That's what that semicolon after the condition, this whole first part of the for loop means. This semicolon means that the for loop has an empty body. And so this never gets reached. This line never gets executed. Which is quite sad. So always include your braces, please. Again, here is another infinite loop. Y starts out being 0, and while y is less than 10, well, yeah, sure, it starts out being 0. It's totally less than 10. We'll execute the body, which is print forever. It's that single statement because there are no braces and no semicolons either now. So now we'll print forever, print that out, come back to our loop guard. This is called a guard. And, oh, yeah, y is still 0. It's totally less than 10. Let's keep on printing forever. All right? And then finally, this one. This one is a bit odd. So the issue with this one is, that always goes into a weird spot. Come over here, please. The issue with this one is the assignment, or the equality check. So what we would like to see is, oh, y is it 0 right now? All right. Is it equal to 2? No, not yet. Let's increment it with this statement. So it becomes 1. 1. And then it's still not 2. Now it's 2. And now it's equal to 2, so we'll stop the loop. But no, this isn't an equality check. Do you see that? This is an assignment. Which does exactly what you wouldn't expect. So it should have been, to be correct, it should have been y equals 2, because that checks for equality. But right now it's y equals 2, which means it's actually going to set y to be 2. Y equals 0, sure it's 0. Check the guard, which is going to assign 2 to y. And then the result, this is the weirdest thing. If you ever want to get the value of an assignment statement, the while loops condition needs to be a Boolean, right? We know this. An assignment statement gives back the value of what the variable is assigned to. In this case, it returns 2. So the result of assigning y to be 2 is just the number 2 itself. So it's like saying while 2. And remember what we talked about Booleans being converted to from ints. 2 is true. So this is like saying while true. And then it'll make y 3 in the body, but then go right back to set it to be 2 again, and continue on this vicious cycle forever and ever. So that is very unfortunate. So watch out for your double equals and single equals. Okay. One last example in the slides today. And then I want to give a brief example of functions. So here is an example of another nested loop. So here's our problem. We want to buy some stuff. Horses cost $10, pigs cost 3, and rabbits cost 50 cents. And here, let's pretend we're a farmer and we want to buy 100 animals, exactly 100, for exactly $100, and we want to know our possibilities. Okay, so how many of each animal did this farmer buy? Or if we're the farmer, how much did we buy? So you could try some fancy math with this, but our computers are quite fast, and it's very easy to try all the possibilities until we find the answer. And this goes back to our nested loops, how we were able to iterate through every single combination of a certain amount of numbers. Here, we need to iterate using a triply nested loop, because we have 3 things to buy. But they'll actually make our lives easier. It'll solve this problem. So let me make a new file called, I don't know, bruteforce.cpp. Using namespace std main. Okay. So the idea is, let's try all the possibilities. We have 100 animals to buy, so it's possible that we could buy 100 horses, 100 pigs, and 100 rabbits, and just nothing of anything else. So let us start off our loop with like this. For int horses, we could buy 0 horses, and we can buy as many as 100 horses. Horses plus plus. Okay, we could also, at the same time, buy a bunch of pigs. Okay? int pigs equals 0. We can buy we can buy between 0 pigs and 100 pigs, because we can just buy nothing of anything else, unless they're equal to 100, pigs plus plus. And then we can do the same thing for rabbits. But it just so happens that we don't have to do a triply nested loop here. We already know how many rabbits we need once we're here, because rabbits equals how many things that you didn't already buy. Rabbits equals, the number of rabbits that you must have bought to make the number of animals add up to 100 is 100 minus horses minus pigs. Okay? That's how many rabbits you must have bought to total up to 100 animals. Okay? And so now we know how, inside of this loop, we have a certain amount of options. So every time this inner body is executed, horses, pigs, and rabbits are set to different numbers. And every time that after we execute all of this, we will have range through every possibility. We will be sure to range over every possibility here, just by virtue of nested loops, because we'll have all those different pairs of things. Okay? So let's see what we did. So we need to figure out if we just bought 100 animals and we spent $100 exactly. So let's figure out how much money we spent based on the amount of things that we just bought. Okay, so let's do cost or something. Yeah, price. Double price. The price of all of these animals is how many we bought of them times how much they were going for. So the number of dollars that we spent in total is horses times 10 plus pigs times 3 plus rabbits times 50 cents. 0.50. Okay, so hopefully this makes sense. And now the idea is, well, what were the answers? If this added up to 100, if price is equal to 100, well, we need to output what we did. So cout the farmer bot. Let's do 100.00 just to be fun. The farmer bot. I don't know, let's make this on a bunch of different lines maybe. Dun dun dun. Horses, horses. Then a certain number of pigs. And I gotta get rid of these semicolons. And rabbits. Rabbits. Okay? So that is the idea there. And let's run this and see if it does the right thing. So we're going to iterate through every possibility of horses, pigs, and rabbits. That adds to 100. Okay? And if we got lucky enough to find the combination that summed to exactly $100, we'll print that out. So g++ brute force dash o brute force. Okay, so here's the idea. Here's what happened. There are apparently two different ways to do this. The farmer bought 0 horses, 20 pigs, and 80 rabbits, or the farmer bought 5 horses, 1 pig, and 94 rabbits. So let's figure this out. Let's go into Python to make sure that this actually worked. So if it's 0 horses, that's 0 times 10, plus 20 times 3, plus 80 times 50 cents. Hey, that's $100. And this adds up to 100 animals. And again, the possibility is 5 horses, $5, $10, plus 1 times $3 plus 94 times 50 cents. And that also adds up to $100 and 100 animals. One thing that you might have noticed that I didn't allow for, or that I am allowing for, is in this case, it's possible for horses to be 100, pigs to be 100, and then rabbits to be negative 100. Do you see that? So it's possible for rabbits to be a negative number right now, just the way that things are executing. It actually doesn't matter in this case, but sometimes it does, and you might want to guard against that. And rabbits is greater than or equal to 0. Okay, in our case, it won't actually change the output. Oops, not Python. I want to run the program. Okay, so that is that. That is a way of a nice application of nested for loops to try all your options. Okay, so that's the end of today's slides. And one thing that I want to do is talk about functions briefly. Now we've already gotten a lot of experience with functions because we've written this main function already plenty of times now. So just briefly, let's make this functions.cpp file, and I'll include IOStream, make a main function, and let's do some things. Let's make an absolute value function. And I don't know, like a sum function that just does the work of the plus operation. And that should do it for us. So what I want to see is cout absolute value of -2 is, and then we'll call our function that we make, we'll call it absolute value -2, you mind? And then we'll also do something like cout sum of 2 and 3 is sum 2, 3. You mind? So right now we don't have these functions. Let's make them. In order to make functions in C++, you give the arguments, but you also give the return type. There's no def or anything like that. So just briefly, functions. The way that you define one is you say return type, just like int main, the return type of main is it's going to return ints always. Return type, and then name of function, the name of the function. And then you have a bunch of arguments with their types. So type 1, argument 1, and it's the name of that argument, or the name of that parameter. And then you can have more parameters as well. So type 2, and then it's name, param name 2, and you can do this a million times. And you finish that off, and then have the body, as it normally is. And you need to make sure that you're always in the body whenever you say return, returning something of type return type, or something that can be converted into that type. So for example, for the absolute value function, it's going to take 2 integers, or it's going to take 1 integer and return back an integer. So it's going to be abs is the name of the function, it takes in an int, call it x, and it returns back an int. Okay? Takes an int, returns an int. So this is going to check things. So if x is less than 0, return -x, otherwise return just x. That'll ensure that x is always going to, the return value is always positive, and sometimes 0. So non-negative, I guess is the right word. And then the sum function takes 2 arguments, so it has 2 parameters, and it's also going to return an int. That is the sum of those things. So sum int x, int y, and it returns another int. And of course, these types can be anything. I'm just using ints right now for an example. So return x plus y. All right. And then there's also, we could say like, hello world. We could make a function to print something. So hello world is a function, takes no parameters. It just says cout hello world, new line. And the fact is, it's not ever returning anything, this function. So functions that don't return anything have a special kind of type. Functions that don't return anything have the special type called void. So if you can just remember that, that's the only real difference to a function that doesn't return anything. So it doesn't return anything. So its return type is void, we say. And this is not really a type anymore. It's just the thing we use to say this doesn't have a return type. All right, so now when we call this function, oh, sorry, I should have said absolute value instead of abs, excuse me. The library function is called abs, and that's why I confused myself. So this does what you think it does, so we'll sum, so we'll hello world, and so our output should be, we should see 2, 5, and then printing out hello world. So let's go ahead and compile and run this. So functions .cpp-o functions. And that's exactly what we see here. So with that, that is essentially everything I wanted to talk about today. I look at my notes and I notice that I do have one thing that I did want to talk about, and that's how to stop your program if there is an infinite loop. So let me just briefly make an infinite loop. Let me change this to a greater than or equal to. Okay, so now I have an infinite loop in this loops.cpp file, and this program's going to run forever and ever. So g++ loops.cpp show loops. So when I run this, it's just going to, oh shoot, excuse me. Let me do, oh gosh, what's the easiest way? Okay, let's just start out at 10. Now it's an infinite loop. Okay, so the way to stop this is Control-C. Okay? To stop a runaway program, you type Control-C into the terminal. Okay, that's all I wanted to say there. So let's make this go back to normal so that you can look at it and use it. And that is officially everything I wanted to say today. So I will see you in the next lecture.